Okay, so here we are. We're going to talk about properties of matter and just give you some definitions and some things to work with so that you can complete assignments. So we're going to learn how properties can be used to classify and identify matter. And windows are made of glass. Obviously, glass is transparent, so you can see through it. And in this case, it has enough force to withstand the water, so the water doesn't fall out on these people. But you can see that the properties of glass allow us to use it in this instance. Um, and so things we're going to talk about: why do all samples of a substance have the same intensive properties? Um, when you look at a sample of matter, is it shiny or dull? Does a liquid flow quickly or slowly? Is a gas odorless or does it have a smell? Those are things that you can pick up with by touch, by looking at them, or even by using your nose. So these are using your senses to determine what the matter does. Properties used to describe matter can be classified as extensive or intensive properties. Obviously, an extensive property, okay, um, is what we're going to talk about here. Mass is an extensive property. Mass of an object is how much matter an object contains. That's something you probably picked up in ICP. And we look at a basketball and a golf ball. The mass of a basketball is greater than that of a golf ball. But volume, right, is how much space the object occupies. Basketball has greater volume than a golf ball. Mass and volume are extensive properties. Now, an extensive property is a property that depends on the amount of matter, okay? So how much you got? What is an extensive property? How much you got? Intensive properties, okay? And we're going to talk about basketball. So let's say the basketball is made of leather. Maybe it's made of rubber, or maybe it's some kind of composite so that you can play with it outdoors. But these materials have different properties. And so the basketball is used then in different playing conditions: leather, rubber, or synthetic. So leather balls, good for indoor play, but not outdoor play. And it's because they absorb water and dirt more than rubber balls do. So if you have a nice leather basketball, obviously you don't play with it outside. Absorbency is an example of an intensive property, okay? So an intensive property is a property that depends on the type of matter in the sample, not the amount. So like leather, whether you have a little bit or a lot, it absorbs water. It doesn't matter on the amount that you have. But mass does. If you have a greater mass than something, it means you have more matter. So an intensive property depends on the type, okay? Extensive property depends on the amount, and that's how they're different. Each object we see here, okay, in this figure, has a different chemical makeup or composition. So if you have a soda can, it's mainly aluminum. In this case, you have a water can, and it's mainly copper. So we know that they have different looks. Matter that has a uniform and definite composition is called a substance. Aluminum and copper are examples of substances. You can also use the term pure substances. You probably see pure substances more than just substances. But if it's the same throughout, so if it's all aluminum or all copper, therefore it's a substance. All right, now here's a key point. Every sample of a given substance has identical intensive properties because every sample has the same composition. All right, so we're not talking about the amount. We're just talking about the substance itself. They have some properties in common, but there are differences between aluminum and copper. Aluminum, highly reflected, used in silver paint. Copper can scratch the surface of aluminum because copper is harder than aluminum. Copper is a conductor of heat or electric current. Copper and aluminum are both malleable, which means you can hammer them into sheets without breaking, so you can shape them a lot easier. So there's some commonalities and some differences between copper and aluminum. Hardness, color, conductivity, and malleability are examples of physical properties. So a physical property, all right, is the condition of a substance that can be observed without changing what the substance is. Like you can bend it, or you can stick it into a fire, and if you burn your hand, it's a good conductor of heat. Those are physical properties. And here's a list of physical properties for some substances, and you can see these substances here are elements and compounds, but the state of matter, their color, where they melt, right, and where they boil. Now, the states that you see here are listed at room temperature, as you can see at the bottom, but just understand that all of these things occur: boiling point, melting point, color, state. Those are all physical properties. They can help us identify. So let's say we have a colorless substance that boils at 100 degrees Celsius and melts at 0 degrees Celsius. That would probably be water. But if it boils at 78 degrees Celsius and melts at 117 degrees Celsius, it would definitely not be water. It would likely be ethanol. So what we would do is we'd look back and we would find melting points and boiling points, and we'd see water and ethanol match those. So that's how we can discover unknown substances, is using physical properties to determine them. Okay, so glass is used to make windows, while copper is often used in electrical wires. What properties of glass make it a desirable material to use for windows? And we kind of talked about that at the beginning. But glass is transparent, so it can be seen through hard, so it stays in place within window frames, and heat resistant. So it helps prevent the transfer of heat from outside and inside. So it allows us to have glass windows, and we don't bring what's outside inside. You want to compile a list of properties of a substance, but you don't have a way to measure mass or volume. What kinds of properties can you determine without knowing the amount of matter in a sample? So you're trying to look at other types of properties. Obviously, you're going to look at intensive properties, right? The amount is extensive. If it's not the amount, then it's intensive. 3 states of matter. Depend on the circumstances. We're going to use water here: water, ice, and steam. Water is a common substance, exists in 3 different physical states. So those are the ones we're going to look at. But most substances can do this. So 3 states of matter are solid, liquid, and gas. A solid has a definite shape and volume. And what that means is the shape doesn't depend on the shape of its container. Something that's solid will stay solid, stay that shape, and will have the same volume no matter what. So the particles in a solid, tight, packed together, very orderly. Solids are almost incompressible, so you can't squeeze them and make them smaller. In addition, they will expand when they heat, but just a little bit. So solids won't change shape no matter what you do to them. Particles of a liquid are in close contact, but they move. Okay, they can flow, if you will, by each other. So that means a liquid takes the shape of its container. So liquids have a definite volume, but not a definite shape. They take the shape of their container. So the volume doesn't change, but the shape can. The volume of a liquid is fixed or constant. Thus, a liquid is a form of matter that has an indefinite shape and yet has a fixed volume. So there's your terms: indefinite shape, fixed volume, or definite volume. Liquids are hard to compress, but they will expand a little bit more than solids when you heat them. And liquids, and the particles get a little more excited. In fact, that's when you start to see phase changes. So gas, like a liquid, a gas takes the shape of its container, but a gas will expand to fill the container that it is in. So when we talk about gases, they take the shape of their container, so they have an indefinite shape and they have an indefinite volume. So it takes both the shape and volume of its container. The particles are really spread apart, as you can see, and they fly around all over the place. So because of this, we can compress them. We can push a gas into a smaller container. So we can take the same amount of gas and put it into a smaller container. Vapor and gas differences. Okay, gas is used for substances like oxygen that exist as a gas at room temperature. But vapors are when you have a liquid and you got gas that comes up from it. So like when you're boiling water and you see steam. Steam is what we would call water vapor. Okay. So it's when a liquid at room temperature, but then it will become a gas as it heats. Okay, so questions. A substance is in a state in which it takes the shape of its container. What state or states could it be in? So it takes the shape of its container. Think about an answer. It could be either a liquid or a gas, as each takes the shape of its container. How can physical changes be classified? So we're talking about physical changes. Here's the melting point of gallium. So if you hold gallium in your hand, you can make it melt. So if you let it sit, it will be a liquid. But if you put it into a fist, you can get it heated up and you can melt it. Again, I wouldn't do this just because safety reasons. You don't want it to melt into your skin. But this is something that happens with the physical property. The shape of the sample changes during melt as the liquid begins to float, but the composition does not change. Melting is a physical change. So what that means is the gallium's a solid, it's still gallium. When it becomes a liquid, it's still gallium. We're not changing what the substance is. So in a physical change, Properties of a material change, but what the material is, the composition, does not change. Boil, freeze, melt, condense are physical changes. Other words that can be used to describe physical changes: break, split, grind, cut, crush. Now there's a difference between these two sets of words. Each set describes a different type of physical change, but again, we're not changing what the substance is, we're just changing its appearance or size. Now, physical changes can be reversible or irreversible. Melting is definitely reversible. If you melt something, right, you can cool it back into a solid. So you can reverse it and freeze it. All physical changes that involve a change from one state to another are reversible. So when we're talking about boiling, melting, freezing, those are all reversible. But now, cutting your hair, filing your nails, cracking an egg, those are physical changes that you can't go back from. You can't your hair can't be reattached, your nails can't be reattached, you can't uncrack an egg. And those are irreversible physical changes. Another question: water boils and becomes water vapor. Is this a reversible or irreversible physical change? If we boil, obviously, it's going to be reversible because it involves a change from one state to another. If you have any questions, please let me know. This will be the first video for 2.1 Properties of Matter.